Okay, let's take a look at number 7 in section 7.5. We're going to evaluate the following integral here. Use C for our arbitrary constant, so don't forget your constant of integration. So we're going to use partial fraction decomposition. It's already set up to find the partial fraction decomposition for this. We have the degree of the top is 2, the degree of the bottom, if you follow this out, is 3, so we're good there. And it's already factored the denominator. Notice this factor here is uh, irreducible quadratic, can't be further factored over the rationals. So keep in mind what that means when we write out the partial fraction decomposition. We have one fraction for the linear factor x plus 1. We have one fraction a over x plus 1. But this degree 2 or quadratic factor will have a fraction of what? Bx plus c over x squared plus 1, right? It'll have a linear term potentially there. So we have to find the values of a, b, and c here to see if we can then find the antiderivative by finding the antiderivative of the partial fraction decomposition. So we're going to do what? Multiply by the least common denominator, which is just this quantity down here. When I do so, of course, I just get 7x squared. Here, the x plus 1's canceled, and I have a times the quantity x squared plus 1. And then here, the x squared plus 1 cancels, and I have bx plus c times the x plus 1. I have one shortcut. Notice if x is negative 1, if I plug that in, I'll find the value of a, because when I plug in negative 1 here, this will be 0. Wiping this out, this will be 0. Negative 1 squared is 1. 1 plus 1 is 2. I get 2a. And of course, negative 1 squared is 1. And I get 7 here. So solving for a, I get a is 7 halves or 3.5. They do want it in fraction form, so we'll leave it that way. And then I'm going to go ahead and find b and c by doing the method of undetermined coefficients. I'm going to just rewrite this same equation, except I'm going to replace a with 7 halves. So now I know 7x squared is equal to this. Let's expand this out and combine like terms. So distribute the 7 halves through. Gives me this. FOIL this out. Bx times x. Bx times 1. C times x. And c times 1. And then combine like terms. So my x squared terms here and here. I'll do 7 halves plus b will be the coefficient of that. My x terms are b plus c times x, and my constant term, 7 halves plus c. So comparing this to the original polynomial here on the left, which is just 7x squared, in order for these to be equal for all values of x, we have to have the coefficient in front of x squared equal to 7. So 7 halves plus b is 7, meaning b must also be 7 halves. Notice 7 halves plus c is our constant term. The constant term here is 0. So 7 halves plus c must be 0. So therefore c is negative 7 halves. And just as a little check, what must b plus c be? That would have to be 0 because the coefficient in front of x over here is 0. And that works because if I do b plus c, 7 halves plus a negative 7 halves, I get 0, and it all checks. And so I have the values of b, I have the values of b, c, and a. I can now plug those in here and integrate those. So let's do the calculus now, replacing a with 7 halves, b with 7 halves, and c with negative 7 halves. So plus a negative becomes minus 7 halves. We get this. Now, this one we can do pretty easily, but what about this one? Well, notice if I let u be x squared plus 1, du is 2x dx, and I can, basically I can factor out of 7 halves, but I'll have an x minus 1 up top. That's not going to work, okay? So what are we going to do here? Answer, we're going to split this up, right? We're going to break this fraction up into 7 halves x divided by x squared plus 1 minus 7 halves over x squared plus 1. This one will be a u substitution. This one is just, notice if I pull that 7 halves out, 1 over x squared plus 1, the antiderivative of that is the arctangent function or inverse tangent function. So here is pretty simple. Let u be x plus 1, du is dx, and I get 7 halves integral 1 over u, which evaluates as 7 halves natural log absolute value of u, where u is x plus 1. And here, if I let u be x squared plus 1, du is 2x dx. Now I've got a 7/2 x dx. So I'm going to multiply both sides by 7/4, right? 7/4 times 2 is 7/2. And so 7/4 du is 7/2 x dx. And so replacing that, I get 7/4 du over u, which is this, where u, of course, is x squared plus 1. And so our final result here, we've got 7/2 natural log of x, absolute value of x plus 1, 7/4 natural log. Notice you can put absolute value, but since x squared plus 1 is always positive for any value of x, always 1 or more, I can leave off the absolute value. And then minus 7/2, again, tangent inverse or arctangent of x. I think in Achieve, you've got to put the natural log this way. I'm not sure how it takes that, but this is fine on the test. Don't forget your plus C in Achieve, it will give you an error. Okay, hope that's good and helps on this one.